Good morning, LAS kindergartners. This morning's lesson is a follow-up to the brain pop that you did the other day, hopefully, on slide, turn, and flip shapes. And then we'll get into a little bit more of geometry, the mathematics of shapes. So I have a number of different shapes up here. As you remember from the video, you can take a shape and slide it left to right or up and down. And you can also turn that shape. Let's do that with the square. You can slide it up and down or turn it. Does it look like something different to you now? I'm going to take this shape and slide it and then turn it. It kind of stops looking like a letter L when you turn it. And this one, a J, you can turn it or slide it. I also want to remind you that you can also flip a shape. And so I'm going to flip this shape here. And does it really look like a J anymore? What do you think? This L, we can flip the piece of paper entirely upside down. You can maybe see it a little bit better there. Does it really ever look like an L again? An uppercase L once it has been flipped. And here, this shape I just call a blob. I'm going to flip it, and it still kind of looks like a blob. But my question for you is it the same shape or a different shape? Here we're going to take our square, which really looks more like a diamond right now, or a rhombus, and I'm going to flip it. We can still, after flipping it, we can still turn it and slide it. Is it still a square? What do you think? Is it a square this way? And is it still a square or still a rhombus? Let's think about that. All right, I want to talk to you a little bit about certain shapes and how they can be either symmetrical, meaning two sides that are the same, or asymmetrical, meaning very, very different. If you have your two hands, well, this is just one hand, but your two hands together are a symmetrical shape. But your hands all by themselves, one hand at a time, it's not a symmetrical shape itself because you can't fold a hand to make it line up with itself because you've got the thumb on one side. So you'll never be able to fold one hand to be able to make it line up with itself as if you folded it. I do want to show you a shape that I cut out from a piece of paper a long time ago. And I cut it out by putting a fold on it and cutting some shapes into it. So this shape has a line down the middle where I folded it, and it's the same on both sides, almost like a mirror reflection. So I would call that symmetrical. A heart very often is symmetrical, and I'm going to put this one up here, and this has the word symmetrical on it, symmetrical. Now I'm going to get a shape that is asymmetrical, and I'm going to put it here. An asymmetrical shape does not have the same thing on both sides. So there's no way that I could fold this and have it kind of make sense. If I tried to fold it this way, it still wouldn't line up with itself. So that is what defines this shape as asymmetrical. So we have symmetrical shapes that are the same on both sides and asymmetrical shapes that don't have a line of symmetry. This is what a line of symmetry is. It's the line down the middle where it could be folded. Here's another symmetrical shape. It is the same on both sides. Here's another symmetrical shape. If I fold it up, I can make all the edges line up. And here is a symmetrical shape. If you fold it in half, all the edges line up. I want to show you this shape because a square is symmetrical in a lot of different ways. It has a line of symmetry running from top to bottom. So I'm going to show you how to fold on that line. And it does line up at the edges. Also, it has a line of symmetry through the middle going horizontally. So you can line up the edges that way. It also has a diagonal line of symmetry here. And another diagonal line of symmetry going from the other corner to corner. So, the square has 4 different lines of symmetry. It has a vertical line, a horizontal line, and vertical lines going from corner to corner. Even when you turn the shape this way, it still has 4 lines of symmetry, from edge to edge and from corner to corner. A circle is fascinating because a circle has so many lines of symmetry. You can fold it this way. You can fold it this way. You can fold it this way. You can fold it this way, this way. Actually, a circle has an infinite number of lines of symmetry. This circle is made out of a pretty small piece of paper, and it would be hard for me to fold it in more than like 20 or 30 different ways. But a real circle out in the world of mathematics has an infinite line of symmetry. Any line going right through the middle to the other end would be a line of symmetry. I'll use my ruler here. So that's a line of symmetry, 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 and that's a line of symmetry. All right, so I'm going to ask you to make some symmetrical shapes. And the best way to make some symmetrical shapes is to take a piece of paper and fold it in half. I'm going to line up the corners and slide my fingers across. And I like to use my fingernail to get a nice crisp edge. Now I'm going to do something with a marker here. That folded edge I'm going to mark so I can see it a little bit better. So now that is the edge that I have folded. So that's the edge I'm going to cut around and make my shape a little bit different. Maybe I'll make it this shape here, that shape there. And let's see how my shape turned out. So it's symmetrical because it has one line of symmetry. That was my fold line. If you want to make a shape that is not symmetrical, you can just free cut any shape you want. And then you will have a shape that is not symmetrical. All right, thank you for paying attention today, and enjoy cutting out some shapes today.